I mean, that's the really great funny part is that, and that's another thing about the well, you need a lot of cheesy generators. Like copper isn't even good enough metal. You can't use copper for the kind of motors, the kind of output that you need to get temperatures of 80,000 degrees and 100,000 degrees to really get to really push the limit of temperatures. You can't use motors that are made of copper. It won't work. It fries the motors. The motors will always fry. When you start loading them up that much, they go. They can't take the load. They can't take the pressure. The only way to get those really high temperatures is you have to use something that can take some heat or whatever. I think anyway. I'm not exactly sure. I could be wrong, but I know that we were using exotic metals for my motors, like tantalum and some of these other things that can take extreme heats or something combination of basically something like that. Anyway, though, but we used like cheesy copper motors at first. We used a lot of cheesy copper motors. I think, yeah, I'm pretty sure when you start getting up to the really high current levels, you start generating a lot of heat. Like the more load you draw off the motor, the copper actually gets hot or something like that. It's something about advanced motors and advanced amount of pressures. You can't use normal things like copper and stuff like that because it just the motors get like red hot or something when you're really trying to get the power out of it or something like that. I don't really know. I just know I was using like tantalum and all kinds of exotic metals for my motors, and like I said, we noticed that we could load them up a lot more, like 100 times more. But it's using exotic metals. They could literally the motors can literally be like red hot. Like I think they used to have films of it where my motors would be running and you could see the windings and the windings would just glow. Like if you look at some of the old films of my motors, you'll actually look at them and you'll actually see the motors and the motors are just glowing, just that's why we had to use asbestos whatever tab. We had to use asbestos stuff on it because the heat from the motors was just too extreme or something like that. I think or something like that. But heat is wasted energy though. I don't know. Anyway, we were messing around with it, and I think yeah, I think you do produce a lot of heat. I don't know. We were working on it though. Anyway, though, but to get those really high temperatures, yeah, I think that's right. If you're doing the psycho bake oven of smelting oven, when you're getting up because it's a heat, it becomes a heat thing because it's the amount of load that you're drawing. That's right. And it's wasted energy. It's true. You're wasting a lot of energy. You're wasting about 20% or 30%. Yeah, I think we were wasting 20% energy or something. We're working on trying to make it so we weren't wasting that energy on heat. But I think when you're going to up to 50,000 degrees over here, your motors get hot over there or something like that. It's something weird like that. Like, because I mean, like I said, we were pumping out. I mean, all that power was going right into that bake oven. It was going right into that smelter. And like I say, it was so hot that the bars going into the oven, like you could take a stick. Well, it was light on fire before, and you could just go, and you could actually just break like any movement of the container at all from the things. Like it was like we were using the most high temperature conductive material we had, basically, and it went out, and it would touch and go into and around, but basically it's like molten almost temperatures in here from the power that's going into this oven, and in order to get the temperatures up to 15,000 and 50,000 degrees. So like any movement at all, and basically the lines would just go. It's like, oh great, they melted again. Like I'm serious, because we're going because we're actually literally going, and it was also like a problem of the heat was transferring back in the rods because conductive is also heat transferring, and then that lit up the whole line or something like that. It was something weird like that, where to get that vial that vase up to 50,000 degrees or whatever. I think it was 50,000 or 100,000 degrees. To get the really exotic metals, you really got to get it like bubbling, practically bubbling molten stuff. But like I said, if you do that, you get tantalum, you get titanium. Like everybody was wandering around looking for a titanium. They're like, "Where's the titanium at?" where's the titanium at? We don't see any titanium. It's like, no. Titanium is created. It is not mined. You can't mine titanium. There is no titanium mine. It is rock that you superheat up to 50,000 degrees. When you get it up to 50,000 degrees, it's like you can't do it in a normal situation. You have to use electrodes. And you have to, it's just like, it almost looks like a nuclear reactor, because it's like these electrodes are like coming through here and you're just pumping in heat. You're pumping in energy, electricity. So like your motors are like glowing. Like they had a film of the motors like rolling, and they filmed the motors. And like at night with the lights turned off, you could see the motors because they were just glowing red hot. The motors themselves from the hydrodynamic thing that were putting out the power to the vial, to the vessel, were just glowing red hot from the load, because there's like, this is like 50,000 degrees, and then those are whatever 1,000 degrees. So it's like the motors were running at 5,000 degrees. I think the motors were running at 5,000 degrees, and it was running at like 50,000 degrees or something like that. Where to get this heat, no matter what, you're going to get a lot of heat over here. I mean, those Westinghouse motors were like godlike. I mean, you couldn't fry them. There was no way, and that's why we had to use asbestos and everything else in order to get that temperature. Because otherwise, whatever you have on there just goes, if you use paper or anything like that's less flammable, it just explodes. And that's why we're using asbestos, whatever, asbestos this, asbestos that, because there was like 2,000 degrees on the motors themselves. So anyway, like I said, we were doing a lot of high, like there's like your normal steel smelting operation, and then there's where we were. We were at like 50,000 degree smelting vial. And like I say, we were accumulating radioactive material on the very bottom of the vial, because like you get gold like right here or somewhere, and then at the very, 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 we were sifting out the elements in the matter. So at the very bottom, we were getting just a little bit of residue of plutonium or something, or radium. I think it was either radium or plutonium at the very bottom. It was coating the vial basically with radium. Like the process, you put in the rock and you get uranium or plutonium, or not plutonium, you get radium or some sort of radioactive material will always settle to the very bottom. And then gold comes out about here, just above it or something. So when the particles are mixing and creating and bonding and stuff, as it floats down at 50,000 degrees, you get uranium. And that's how we also knew basically a little bit about the sun and everything else, because, we saw it in the vessel. The vessel, which was glowing white hot. Like I said, at night, it was just like, we would light up the whole canyon because it was so bright. We had to put up a block wall around it because it was too bright. People couldn't look at it. It's like, even during the day, it's like, oh, fuck, that thing's bright. And so everyone was wearing sunglasses, so we put up this shield wall to protect people from seeing it, and then it would just beam to space. And then the shield wall was like heating up too much. Like, I was laughing at it. I was just laughing the whole time because like the shield wall was actually getting too hot and starting to melt, and we had to use brick or something like that. because this thing is at like 50,000 degrees, which is insane. But we're getting some real results where you're getting titanium out, you're getting, you're starting to get plutonium residue, you're getting all the high-end elements that are basically sifting out of this granite rock and stuff. And you just pour off the slag off the top. It's like that much of slag is no good, or aluminum or something. You get aluminum. You get a couple different elements or something like that when you're going up to that temperature. Like that's why it takes so much power to create aluminum, because you're actually creating all these other. You're not just you get aluminum. You get like 30% aluminum, so much percent of this, so much percent of that, and so much percentage of iron oxide or something like that. There's iron oxide and there's all these other ones. So. Anyway, and then you get gold, a little bit like 1% gold every time or something like that from the rock. So, that's how you make gold. And everyone's like, oh, what's gold? How do you get gold? Where's the gold mine? It's like, well, actually you got to get up to about 50,000 degrees or 100,000 degrees, and then you start seeing gold. It'll start to bond and create. At those temperatures, like basically the rock and everything, it's just like being in a volcano. And it's starting to and that's how you do it.